In this section, we're going to be solving equations using the square root property. So in these equations, we're still going to be solving for x, but we're going to be using our knowledge of how to find the square root of a number in order to find the answers for x. First problem we're going to look at is 3x squared minus 4 is equal to 68. So in order to solve for x, I need to do everything I can to isolate x, to get x to be the only thing on one side of my equation. So the first step I'm going to take here is to add 4 to both sides. That will cancel out this negative 4 and leave me with 3x squared is equal to 72. Now if this problem would have just been 3x equals 72, I would have divided by 3, so I'm just going to do the same concept of dividing by 3, which would leave me with x squared is equal to 24. Now when you solve problems using Pythagorean theorem like you did last year in geometry, the last step when you have some variable squared equals some number was to take the square root of both sides. So by taking the square root of x squared, that leaves you with x. And now I have the square root of 24. The reason we do this is because, of course, the radical here will eliminate the 2 as the exponent, but whatever I do on the left-hand side of my equation, I have to match on the right. So now what I have to do is simplify the square root of 24. I want to know two factors that multiply together to make 24, but I want one of those factors to be a perfect square. So the two factors that I'm going to use are 4 and 6. So x is equal to 2 times the square root of 6. Now normally we would say that the square root of 4 is equal to 2, which is correct. But the square root of 4 is also equal to a negative 2. So we're going to say this is a positive or negative 2 times the square root of 6. The reason is if I square 2, that will give me 4. If I square negative 2, that will also give me 4. So that's why I will use that plus or minus sign, the positive and negative sign here in this problem. Let's look at the next problem, number 2. X minus 2 squared is equal to 16. So we're going to start out the process of solving for this equation by taking the square root of both sides. By taking the square root of both sides, it eliminates my exponent. So you can kind of see a trend here where I'm trying to eliminate the exponents. So that will leave me with x minus 2 is equal to plus or minus 4. Now, in order to solve for this problem since I have plus or minus, what this is telling me is that my x minus 2 could equal a positive 4, or my x minus 2 could equal a negative 4. So I'm going to have two separate answers for this equation. On this side, my answer is going to be x equals 6. On this side, my answer is going to be x equals negative 2. So those will be my two answers for number 2. Let's look at the next problem, number 3. Number 3 is going to give me a trinomial. X squared minus 10x plus 25 is equal to 16. Now, this trinomial here can be factored. It can be factored to look similar to what it is on number 2. What I need to know is what are two numbers that multiply together to make C, but add together to make B. And those numbers are negative 5 and negative 5. Since they are the same number, I'm allowed to say x minus 5 squared equals 16. So all I did was I rewrote this equation after I factored out this trinomial. And then I'll go through the same steps that I did on number 2. Take the square root of both sides, get x minus 5 equals plus or minus 4, and then solve by rewriting both of those equations by setting x minus 5 equal to positive 4 and x minus 5 equal to a negative 4. So x here will equal 9, or x will equal positive 1. So the last part of this set of notes, what I want you to do on number 4, is I want you to solve just like we did on number 3, x squared minus 2x plus 1 is equal to 36. So I want you to solve this problem. There might be some radical simplification going in there. You never know. We'll see what happens. But go through and solve for number 4. And that's what you need. You need to have that done if you want to receive credit for this set of notes.